Here we've got a broccoli. And this is an important vegetable, not to everybody's taste, obviously. So what we're trying to do with broccoli, obviously, is to stop it going yellow. That's the main reason why it goes off. It loses its green colour. Like with most fruit and veg, you can store it cold, but at the supermarket they don't put it out under chilled conditions. And so we're looking at novel ways of extending the shelf life that don't involve refrigeration. Rather perversely, we've come up with, treat and mean approach. So plants have this ability that if they're put under stress, so if they're subjected to high temperatures or exposed to ultraviolet light, the sort of things that give us a tan and skin cancers, they respond by trying to protect themselves. And part of that protective mechanism means they last longer and they don't degreen. So we're trying to exploit this.
This is a cabinet we use for treating fresh produce with UV. So there's a screen here which I'm going to remove. We've got a UV source which is movable, so we can change the intensity of UV light that actually impacts on the produce. So front cover off. Sample fits in between these two rollers. Safety cover back on. Turn on the source. It is actually stressing the produce, and it's the response to that stress that we're making use of. And when we've treated it, we want to measure the colour of the fruit or produce immediately thereafter, and then we store it under either room temperature in a cold store, and then we periodically make measurements of the colour.
We would go out and buy a factor 30 sun cream and slap it on our arms. What the plant does is it starts to produce antioxidants, more vitamin C, more phenolics. And a side effect of that is that it doesn't lose its colour as quickly. So you UV treat this broccoli and it'll last for 2 or 3 days longer. Now that doesn't sound much, but that's a really commercially significant extension to the shelf life.
We want to get quantitative measures of the colour of the treated produce, so we can't rely on the eye. And so we've got this instrument here which takes objective measures of the colour. So I place it on the treated produce, press, and we get a reading, and we use that to plot the changes in colour over time under the storage conditions. This is results of a previous trial we've run in which we've measured the colour, which we record on the y-axis, over a period of time, 10 days, and you can see the treated material in red has pretty much kept its colour, whereas the control material, that is the produce we didn't treat, actually became more yellow over these 10 days. And we've got a shot here which shows the treated broccoli maintaining its green coloration after 9 days, and the untreated control which has visibly gone yellow.
Commercially, this isn't feasible. No one is going to be able to treat a field of broccoli for 10 minutes with a UV light. So what we're trying to do now is trying to increase the intensity. We're trying to make the UV light stronger and seeing if we can cut the time down. And we've increased it 5-fold and reduced the time 5-fold, but it's still down to a couple of minutes.
We want to be able to mechanise the whole process. We're looking at, for example, when the broccoli is harvested from the field, it's put onto a conveyor. We want to see whether we can incorporate UV sources on that conveyor so that as it's conveyed into a truck or a container, it's being treated.
We have had instances where we've tried to go to very high intensities. That requires, in our situation, having the lamp very close to the broccoli. And you end up with a nice green broccoli, with a brown cap where it's got burnt. So it is a fine line.
You said at the start broccoli's not to everyone's taste. I admit I don't eat my broccoli. Tell me about you.
I quite like broccoli. I have it as often as possible. Unfortunately, half of my household, the kids, don't agree with my taste.